So welcome to the very first lecture on the discrete random variable, where we'll discuss a problem on discrete random variable. In the last learning video we have seen the definition of random variable, discrete random variable, continuous random variable, and under the topic of discrete random variable, we have seen two definitions. Which are those two definitions? One is of the probability function and the second is of the distribution function. Okay, so we'll need to recollect those definitions in order to solve this problem. So what is probability function? So you just need to, whenever the probability function strikes in your mind, you just need, the two things should be strike. One is the all the probability should be greater than 0, and the second condition is sum of all the probabilities equal to 1. Okay, and for the distribution function, it is a cumulative distribution. So what we need to remember is the initial value should be 0, and when you have a cumulative distribution, then the final answer comes out to be 1. Okay, we'll see how to solve the problems on it. Okay, so first of all, what is given to us? Let x be a random variable given the number of tails in 3 tosses of a fair coin. So what is the experiment? So the experiment is of tossing a fair coin 3 times. Okay, so let us start with the sample space. The sample space is given by, the sample space S is given by. Now I want you to write down the sample space. If you toss a coin 3 times, then what would be the possible outcome? So just pause the video for a few seconds and write down the sample space and then resume the video. I hope you might have written the sample space for this experiment. Okay, now let me tell you the trick to write down the sample space. Okay, suppose if you are if you are getting some difficulty in writing down the sample space, so just write down the sample space for 2 coins. So for 2 coins, what is it? Head, 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 tail, tail, head, tail, tail. Okay, so this is the sample space for 2 coins. Very simple. So for 3 coins, what you need to do is you just need to repeat it again. So again, this should be there. Heads, head, tail, tail, head, and tail, tail. Done. Now what you need to do is, in the first 4 elements you write heads, and in the next 4 you write tail. So in this way you can write down the sample space for a random experiment when a coin is tossed 3 times. Okay, so how many elements are there? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so these are the possible outcomes. So what is my number of elements in the sample space? 8. Okay, now let us define the random variable which is given to you. So what should I write? Let x denotes, what is it? X denotes the random variable. Of course, x is a random variable for number of varieties, number of tails it is. Okay, so it is x denotes the number of tails, then if it denotes the number of tails, then what is x? Then x can be written as, how many tails are there? 0. Okay, then how many? 1 tail, 1 tail. Okay, 1 tail. So for these in these 3 outcomes, number of tails are 1, and in the remaining 2 tails, so 2 tails, and then in the last one we have 3 tails. So avoid repetition of the number of tails. Don't write it like 0, then 1, 1, 2, 1, 2, 2, 3. Don't write like this. So this is my random variable. Now see the values this random variable is taking. This random variable is taking the values 0, 1, 2, 3. So this is a problem of discrete random variable. Okay. So we have a problem of discrete random variable. So we have, this is my, if you compare with the definition, this is my x1, this is x2, this is x3, and this is x4. So let us find out the probabilities. So what is the probability of x equal to 0? So probability of x is equal to 0 means, probability of x is equal to 0 means 0 number of tails. 0 number of tails means it is a probability of heads, heads, heads. Okay. So you can find out like number of favorable outcomes, number of favorable outcomes upon total number of elements in S. So what are the number of favorable outcomes for tail 0? So or all the heads. So how many outcomes? Only one outcome. So it is 1 by 8 because number of elements in the sample space is 8. Now it becomes interesting to find out the probability. This is just like school days probability. Next we have to find out probability of x is equal to 1. So how to find out probability of x is equal to 1? What is x? X denotes the number of tails. So see the number of one tail in the favorable outcome. So how many number of one tail? So we have 1, then 2, and then 3. So these are the favorable outcomes where we find out only one tail. So this is 1, 2, 3. So this is 3 by 8. Okay. Now go for finding out the probability for this. Probability for x is equal to 2 means, now look for the favorable outcomes where you have two tails. So this is 1 and this is 2 and this is 3. So again the number of favorable outcomes is 3 divided by the number of elements in the sample space. And finally for number of 3 tails. So can you see in the sample space how many favorable outcomes are there where you find out 3 tails? So we have only one outcome where you find out 3 tails. So what is the favorable outcome? 1. And how many number of elements are there in the sample space? 8. So 1 by 8. Now we have to write down the probability. We have to write down the probability function. So what does probability function says? Probability function says for all the elements of the random variable you find out probabilities. Okay. And what you need to check whether all the probabilities are greater than 0 and sum of the probabilities equal to 1. Okay. So I can write number 1, the probability function, we denote probability function by f of x. Probability function f of x is equal to, what is f of x? Sorry, is given by what? You just need to draw a table, small table you can draw. So this is a table. Now you have say the values of a random variable, say x, and here we have the corresponding probability. Why I am saying this f of x to be a probability function? Because it satisfies both the condition. What is it? The first condition, all the probabilities are greater than 0, and what is sum of the probabilities? This is like 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by. So what is it? 4 plus 4, 8. So this is 8 by 8. So this get cancelled 1. That is why I am writing it is to a probability function. So what are the values that we have for the random variable? We have values 0, then 1, then 2 and 3. And the corresponding probability that we have found out is 1 by 8, 3 by 8, 3 by 8 and 1 by 8. So this completes the half one problem that we have to find out. So this completes the first part, which says you have to find out the probability function. Okay, now we can find out the distribution function. But before that, let me tell you how to show it diagrammatically. Okay, so I will do it here itself. A short one. Okay, so this is my origin, and what are the values of random variable x, and the probability function f of x. Here it is f of x. Okay, now what values we have? I am drawing it as a bar graph. Okay, so what it should be for values of x is 0, then we have 1, then we have 2 and we have 3. Okay, and probabilities f of x values, you can take it as 1 by 8, 2 by 8, 3 by 8 likewise. So it is say 1 by 8, 2 by 8, 3 by 8. Okay, so for 0 we have, drawing the bar graph, for 1 we have probability 3 by 8. So it should be like, okay, and for 2 also we have 3 by 8. Okay, and for 3 we have 1 by 8. So this is the graph for the probability function. Okay, now let us see the distribution function f of x. This completes the first part. Second part says the distribution function f of x. The distribution function f of x is. So what is distribution function f of x? Just write it down. F of x is equal to, I have already told you that you have to start with the 0 and value will be having minus infinity less than x less than first number, which is x1 is 0. Okay, so 0 for second, 0 less than equal to x less than second one, that is 1, and then we'll be having 1 less than equal to x less than 2, and then we have 2 less than x less than 3, and at last we'll be having 3 less than equal to x less than infinity. Okay, so now you have to just substitute the values. So for what is the probability for x is equal to 0, we have 1 by 8, or to get the feeling of cumulative distribution, you can write 0 plus 1 by 8. For the probability of x is equal to 1, you can write 1 by 8, the cumulative, so we have to add this, and for x equal to 1 we have the probability 3 by 8. Okay, this is for this. Now for x is equal to 2, we have the probability 3 by 8, so I have to write it like 1 by 8 plus 3 by 8 plus 3 by 8. Okay, and at last for x equal to 1 by 3, what is my probability? My probability is 1 by 8 plus 3 by 8 plus 3 by 8. This is the previous one, and for x equal to 3 we have the probability 1 by 8, and when you sum up all these you'll be getting 1. So this is nothing but the distribution function for the given random experiment. Now if you want, I can draw a graph for it. So let us draw a graph for this. So the graph for this is, let me write here, graph for f of x. Okay, then you have to draw the x-axis and y-axis, is it? So in the x-axis, what you'll be having, just like the previous one, here it is. So in the x-axis you'll be having x, and here you'll be having f of x. Okay, so here it is, say 0, 1, 2 and then 3, and here you have the values 1 by 8, 2 by 8, and then here it is 3 by 8. Okay, so for 0 is equal to 1, what we have, you have the values this. So this is for x is equal to 0, the probability is 1 by 8. So you can write here 1 by 8. Now for 1 we have the probability 3 by 8. So what you need to do is just draw like this, and for this we have what? We have the value 3 by 8. So let me draw this 3 by 8. Okay, so see the distribution, huh? For 0 we have 1 by 8, and for this we have 3 by 8. Okay, so I'm just adding 3 by 8. Okay, so 1 by 8, 3 by 8 would be 4 by 8. Now for 2 I am having value 3 by 8 again. So again I will be adding 3 by 8. By 8. Okay, so it is like I'm adding this 3 by 8, and for this equal to, for 3 we'll be having the value 1 by 8. Okay, and the probability would be say I'm having the value, say 1 somewhere here. So this is the value will be having 3 by 8. Okay, so 1 by 8, this should not be the case. 1 by 8, then I will write here, let me write, okay, this much value is 1 by 8, and then this value is how much it is, 1 by 8, 3 by 8, 4 by 8, which is 4 by 8 means 1 by 2. Okay, then 1 by 8 plus 3 by 8 plus 3 by 8, what is it? 7 by 8. So this value would be 7 by 8, and this should be 1. So let me extend this to some level. So this is, say, 1, this is 1. So say here somewhere we are getting the value as 1. So okay, and this value is 1 by 8. This value is 3 by 8. So in this way you can just show it the graph of the distribution function. Okay, so this is what we have. If you want, you can just make this as dark. So any number which is in between, which is greater than 1 but less than 2, will have the probability, that's 3 by 8. Okay, so you can actually verify the same thing from here itself, from values which is equal to 0 but less than 1, equal to 0 but less than 1, till here all the values are getting the probability as 1 by 8, and all the values which is greater than 1 but less than 2 having the probability 3 by 8, and so on. So I hope this video lecture is making sense. If you want to do the problem, same problem, what you can do, I have done it for the number of tails. You can draw the you can go for the same problem, instead of number of tails, just change to be number of heads. Okay, so You can have a problem on it and you can solve, and not just solve but try to draw a graph for this. I would like you to draw the histogram for the probability function. Okay, so thank you for watching this learning video.